please follow along with me. When I look at number 2, I'm going to abbreviate here. Please write down DEG for degree. Underneath it, I'm going to write a capital LC for leading coefficient. Then I'm going to write down solutions. I'm going to list how many there's going to be, and will write the solutions at a later time, and I'm going to identify what the y-intercept is. My goal is to draw a rough sketch of this particular polynomial function. So, how do I identify the degree in number 2? Let me zoom in for you. I'm looking at what is the highest value on a variable, 3, 2, 1, and 0. So 3 is the highest number. 3 is an odd number. Then I'm looking at the number in front. 2 is a positive number, and I'm abbreviating. This degree tells me how many solutions, so there's going to be 3 solutions. And now it's time to get started. So I'm going to come off to the side here, and I'm going to write down this function. And I want to solve this using the skills that we practiced last week. So I'm writing down 2x cubed plus 3x squared minus 32x minus 48. And I'm going to set this equal to 0. Underline the first 2 terms. And this is where I think the major confusion is what do I factor out? So I want to slow this down. What numbers are factors of 2, 1 and 2? What numbers are factors of 3, 1 and 3? The only number that's a factor of both 1 and 2 and of 2 and 3 is 1. So I'm going to factor out a 1, and the most x's I can take out would be x squared. 1 times what value is 2? 1 times what value is 2? The number is 2. But I need 3 x's and I only have 2. Put 1 more down. 1 times what value is 3? 1 times what value is 3? The number is 3. I need 2 x's and I already have them. I'm going to take whatever's in parentheses, I'm going to write it in back, and I'm going to put a really light question mark in front. So what value times 2x achieves a negative 32x? You maybe need to take a calculator if you're not great with mental math and take negative 32 and divide it by 2. What number times positive 2x gives me a negative 32x? The answer is negative 16. Negative 16 times 2 is negative 32. I have the x. And negative 16 times 3 is negative 48. So there's a front and a back to this. Both the front and the back contain the quantity 2x plus 3. So I write it down one time, 2x plus 3. Now, what's in front of the 2x, the first 2x plus 3? It would be a 1x squared. What's in front of the second 2x plus 3? It would be a minus 16. These quantities are called factors, and I'm going to take each factor, I'm going to set it equal to 0, and I'm going to solve. So I'm going to start by subtracting 3 to the opposite side. Bless you. And dividing by 2. X equals negative 3 halves. Now, if you're like me, I really like working with decimals better, especially when it's called a terminating decimal. A terminating decimal are things like this: 2.5, 3.5, maybe 1.75. A non-terminating decimal is like 1.22222 or 3.3333. So, what is half of $3 for those that like to work with money better? What's half of 3? 1.5. So this is negative 1.5. So when we graph this, if you like thinking of it as a decimal, notice that 3 over 2 is the same as 1.5. Okay, let's go to the next one. I'm going to add 16 to both sides. Dividing by 1. And now this tells me I have 2 solutions. How do I achieve those? Well, when I take the square root of both sides, I have a plus or minus, and the square root of 16 is 4. So I have 3 solutions. Notice this, I have 3 solutions. Now it's time to list them. So I'm going to write down negative 1.5, but you could write down the equivalent, which is negative 3 halves. And then there's 4, and there's negative 4. Okay, let's come over here. 1, 2, 3, 4. That's one of my solutions, or x-intercepts. 1, 2, 3, 4. That's another one. And negative 1.5 is right about there. The next one, if we're smart, we can just do mental math. I'm going to show you how to use a calculator if you don't feel confident with your mental math. But let's look at this. Whenever I find the y-intercept, I always turn all of the x's into 0. So 0 times anything would make this portion 0. 0 times anything would make this portion 0. 0 times anything would make this portion 0. And I'd have 0 and 0 and 0 minus 48, which would be negative 48. Now, not all people feel comfortable with that math, and so you don't have to do this, but I do want to recognize here's how it could work. So I could go 0 to the third power, and then I could go plus 3, 0 squared, and minus 32 times 0, and then I'm going to go minus 48. So I just plugged in this original function and replaced all the x's with 0. We get the same answer of negative 48. So there's no way I'm counting all the way down to here to 48. So I'm just going to make like a dot down here as far as I can. Just not possible. I'm not taking time to make 48 text all the way down. Okay, I want you to turn to your partner, or do this yourself if you're watching this video. And I want you to remind your partner, forget about the fact that we're eventually going to say leading coefficients are positive. What two options do you have when you strike a pose if it's an odd degree? Turn to your partner. What two options do you have if it's an odd degree? I'm seeing wrong answers, so talk to your partner. It's either right hand up, left hand down, or left hand up, right hand. So one of those two. Now turn to your partner. What does it look like when it's positive leading coefficient? Okay, it's your right hand is up, your left hand's down. So watch this. Watch, watch, watch. Right hand's up, left hand's down. Okay, next I want to review with you. Please look up here. Please look up here. If you were gone yesterday, you're definitely going to want to find a place to write this down. If you were here, you can simply watch. If you were gone yesterday, you definitely want to take a chance to write this down. Yesterday we talked about what does it look like when there's just one of one type of solution. So I'm going to write one solution. If we have a duplicate solution, an example of that is like x equals 2, x equals 2. Angel. If we have three solutions, so example, x equals 1, what if it happens twice, or what if it happens 3 times? What does it look like? And what words did I use yesterday that are not math terms? So if it only occurs one time, so we only have one solution of x equals 1, it means it's going to slash through. It goes straight through the x-axis. If we're comparing the function with the x-axis, how it actually crosses over or touches the x-axis, it just cuts straight through. Now, what if we got two solutions and they were duplicates? Then it means at 1 it bounces off. So it could look like this. It bounces off the x-axis at the point 1. Well, what if we had three solutions? So 3 times in one problem, we got x equals 1, x equals 1, x equals 1. Then it snakes through. So an example comes from the bottom, and by snaking through, once it gets to that point, it's going to level off with the x-axis, and then it goes back up. So it kind of snakes through. All right, so how is that going to help us with this problem? How many times do we have a solution of negative 1.5? One time. So it's just going to cut straight through. It's going to slash through the x-axis. How many times do we have a solution of 4? One time. So it's just going to cut through. How many times do we have a solution of negative 4? One time. So it's going to be like this. It cuts through, and it cuts through, and this problem is done. Number 4 looks so much more confusing than it is. It looks so much more confusing. And you know why it's confusing for students? Because we hate working with fractions. Do you agree if it wasn't 1/2, it wouldn't look so scary? So we want to remove that 1/2. In fact, let's remove the negative 1/2. So I'm going to come off to the side first of all and write degree, leading coefficient, solutions. I'll list those solutions later, and y-intercept. All right, so let's get started here. What degree is this? This is degree 3, because the highest exponent on a variable is 3. So that also means, by the way, that we're going to have 3 solutions. Now the value in front of that term, this is called a term or a group. Term is the correct math term. The value in front is negative, so this is going to be negative, and I'm going to abbreviate. Okay, let's get started here. So I'm going to write down this original problem. And I know that I personally don't like working with fractions. And so I'm going to factor out a negative 1/2. But then I analyze the 3 groups that are called terms. Term, term, term. And I notice they all have an x. Turn to your partner. What's the maximum number of x's that you could take evenly out of each one? 1. Now some students would say 2. Yes, you can take 2 here. Yes, you can take 2, but this doesn't have 2 to take. So we can take out 1 x. Now here's where you're going to grab your calculator, unless you have great mental math skills. Grab your calculator. And ultimately, in order to get this, we want to know what number times negative 1/2 gives us a negative 1/2. That's going to be 1. And is there a different way we can do that? Yes, take this number, we're going to put it in parentheses and divide it by the number out front. And that's ultimately how we get this value. We need 3 x's, that means I need 2 more. I take this top number, divide it by this bottom. Watch. I take negative 4 in parentheses, and I divide it by the negative 1/2 out front. And that's going to give me the next term, which is positive 8. I need 2 x's, that means I need 1 more. Lastly, I take the top number, which is negative 8, and I divide it by the bottom number, which is negative 1/2, and I end up with a positive 16. This is what I'm focusing on. I'm going to come back to this later, but this is what I'm focusing on. In order for me to solve, I always make that f of x or y equal to 0. Okay, this is what I'm focusing on. So I'm going to make my little x here. 1 times 16 is 16. So I'm looking for 2 numbers that multiply to give me 16 and combine to give me a positive 8. Go ahead. What are those 2 numbers? Talk to your partner. What are they? 4 and 4. What type of 4s? Positive 4. Positive 4. So I'm only worried about this trinomial, 3 things trinomial. So I write down the first term, I leave a big blank, and I write down the last term. And in the middle, I'm going to write down the 2 values I have, but what's confusing is what goes behind the 4s. We always look back to the b term, and whatever is behind the b, in this case it's just a singular x, goes behind both. Okay, let's underline the first 2 terms. Underline the first 2. What is the largest number that I can take out of 1 that I can also take out of 4? Now, if that confuses you, watch this. The only factor of 1 is 1. The only factor of 4 is 1, 2, and 4. 1, 2, and 4 all nicely divide into 4. So what's the largest number in both lists? 1. What's the maximum number of x's I can take out? 1. 1 times 1 is 1. I need 1 more x to get x squared. 1 times positive 4 is positive 4. I need an x, and I already have it. If you're feeling confident, I'd like you to continue to work ahead. I'm going to take this and copy and paste this in back. And I'm asking myself, what value times 1x would achieve a positive 4x? What times 1 is positive 4? The answer is positive 4. And I'm going to make sure that's right. That's 4x, and that's 16. That's good. Now, both the front and the back contain the parenthesis 1x plus 4. They both contain this, so I'm going to write down this one time, 1x plus 4. Now, what's in front of the first parenthesis? 1x. What's in front of the second parenthesis? Positive 4. Does everybody see how it's the same thing twice? So if I solve it one time, there's no need for me to solve it again because I already know what the answer will be. I'm going to subtract 4. I'm going to divide by 1. And I get an answer of negative 4. And over here will be the exact same thing. Now, if you're really methodical about this and you want to show all your work over here, then go ahead. But x equals negative 4. So I get negative 4 twice. Okay? Remember, I'm supposed to have 3 solutions here. I know 2 of them are negative 4 and negative 4. Just like example number 2, your first example, which was number 2, now I need to take that portion out front that we factored out, and I need to set it equal to 0. Now we can do some mental math here. What's the only number you can take times anything and get 0? What's the only thing you can take times a negative 1/2 and get 0? 0. So the answer is 0. So 0 times negative 1/2 is 0. 0, negative 4, and negative 4 are my answers. So over here I have 0, negative 4, and negative 4. So let's go to our graph. Let's locate negative 4, make a dot, and locate 0. And let's now identify the y-intercept. So that means when I plug 0 in. So 0 cubed times this number is 0, and 0 squared times this number is 0, and 0 times 8 is 0. So 0 plus 0 plus 0 is 0. Now, again, if you didn't feel comfortable, I'm not going to go through it this time, but what I could do is I could plug in all of this just like this. I'm not going to continue to go through this, but I could plug this all in all the way through. Oh, that should have been a negative 1/2 divided by 2, and we get the same answer of 0. All right, here we go. So at 0, it's going to just cut through because there's only one solution, but at negative 4, it's going to bounce off. I want you to strike a pose and turn to your neighbor. If we have degree 3, which is odd, and we have, so degree 3, which is odd, and we have a leading coefficient, which is negative, what would that look like? Turn to your partner. What would it look like? Left hand goes up, right hand goes down. Please do that on your graph. Left hand goes up, right hand goes down. Okay, so it needs to bounce off at -4. So we can see it's already coming this way. To bounce off, it's going to go back up. Now it bounced off. And then it needs to cut through at 0 because there's only one solution. And then it cuts through. And this problem is done.